ask? You sent me the email, right?
Yeah.
I was gonna cover that today, but we may start in a minute. I may need some nutrition to get myself going. So if you don't mind, I may take a 5-minute break and go eat a cracker.
Did it just go out? Did the lights just go out? Or? Oh.
I don't know. Were those questions those were in the second group, right? The ones with the second homework or the first?
It's first homework.
First homework, okay. You wouldn't happen to know the numbers, do you? I guess maybe I could figure it out. Let's see. Let's just try that one to see if that one's it. Wait a minute. That's a weird view. Oh, that's not it. Oh, I think I can do the arrow here and it goes to the next one. So it's not that one. Wait a minute. Wait a minute. Whoa. Okay, wait. Maybe it's that one. Oh, that's one of them. Okay, so the other one has to be in front of that one, right? No? Okay, that was one of them. Was that one of them?
Yep.
Okay. Well, let me go back to 11 and see if that was one of them. That wasn't one of them. So let's just do or poke around at this one. Okay, I can't make it go down, so part of it's not on the screen. There are two screens. This one matches the thing and this one does not. Okay, so it just says in figure f is equal to 7. So that's that thing. But I think I have to scroll up here. Okay, it says determine the magnitude of the resultant force acting on this thing. That's the screw ice. So I guess we can call this F. I guess we'll call this one F1. And so if you look at it, F1 is just equal to, all right, it's 2. You know what? I'm just going to not write that and just say everything he's writing is kilonewton. So I think in here you've got to put that. So what I've got is I've got a component going that way. So I've got 2 times cosine 45i is going to the right. It's up to you to decide whether you want y to go this way. Generally, people do. And so I'm going to go ahead and make it go up. You can make it go down, but I wouldn't. I'd just make it go up. And so that means this thing goes down to sine of 45j. Now, this one is 7. But in yours, it might be different. I don't know. It might be 7, it might be something else. So in this one, you got 60 going backwards. And this one going. So this is going in the x direction. So this, I'll call it F2. F2 is 7. It's going backwards this way. It's going 7, and this is the 60 degrees. So cosine of 60 degrees I. It, in addition to it going down, this one's going down. Well, so is this one. And so it's 7 sine of 60j. And so now if I just scratch that out and say I'm going to add the two of them, then I'm going to say the resultant is going to be this together times I, so it would be 2 cosine of 45 degrees minus, and I was going to write plus, but that's not. So minus 7 cosine of 60 degrees, and then say I, and then I'm going to take these two, put them together up here, so that's going to be minus 2 sine of 45 degrees minus 7 sine 60 degrees j. So out of these two, you'll get two numbers. I don't know what those numbers will be, but you'll say FR is equal to whatever number you get out of that first one, I, plus whatever number you get out of that second one, J. So this will be that number, and this will be, so I'll call that number 1 and number 2. This will come out of here. So he wants to know the magnitude of that force. So if you want to know the magnitude, all you do is the square root of whatever number that was squared plus whatever number that other one was squared. So you take the x component, this came from the x component, this came from the y component. You just square it, and that's your number that goes in. Okay, so he's obviously, okay, when he does that, okay, let me put it to you like this. When you get a resultant, you'll get some number 1, I, plus some number 2, J. From that, you can determine some information. But you have two numbers. So likewise, he's going to often want, oh, that's my part, he's going to often want this. The magnitude equals to a number 3, and he's going to want to know like an angle. So sometimes I wish he would draw the thing instead of doing it, but often, let's say, okay, I know both are going to go down, so it's going to go down. I'm thinking with this, and that's 3.5, and that's right. I think it's probably going to go to the left. I think it's going to go down and to the left. I think it's going to go down a lot, to the left a little. So it's going to look like that. That's what I think. I might be a little wrong on that. And then he's going to say, determine the direction of resulting force acting on this grid measured clockwise from the x-axis. Okay, so clockwise, tick tick goes that way. So he's going to want to know that. Now, here's the problem. This is he does this several times, and I don't have any control over it. I think it's kind of weird and bizarre, but it's okay. So let's say this was 210. So obviously, if this becomes 210, you enter 210. But there are times he's going to ask you for the minus number, and you don't know it. And so you enter it, you get a wrong answer, and you're like, what? So let's just say this was 210. I don't know what the number is. But then if you want to enter it the other way, it's 210 minus 360. Or what is that? Minus, take away 1, that's 5. It's 150, is that right? So 1 of 5 and 1 is 6. And yeah. So what is the answer? Is it 210? Is it plus 210? Or is it minus 150? He's going to ask you for one of them. You may enter one and he says, that's wrong. But you may look at it and say, am I wrong? I don't think so. And then try the other one and you may find it to be right. I don't know why he does that. Am I making sense on that? Does that kind of make sense? So it's kind of like, I don't know what that's like. I'm trying to find an analogy, but it's kind of like stupid. How about that? Because usually, if he's asking you for that, I just don't know. It bothers me. But if it bothers you, just understand that that's what he's done. That's the reason there's 6 attempts. Just go back and do it and flip the angle over, and what you're going to find, you'll probably find you get it right. Because there's a couple in here that ask you for something like that, and the correct answer he has is a minus, and you're like, that's just plain stupid. It would be better in my mind. So usually what he does is he'll do this. In the back of the book, he'll say this. So the number, so this is the way he presents his answers in the text. He gives a reference, a direction, and you can visually see the 210, that's a number, but then you can see what it's associated with, the angle between here and a vector going that way. You'll see other times he'll do this little symbol where it goes like this, or I've seen it where it goes like this. So he gives you this, but he doesn't use this on his things. He just asks you verbally the thing. So I have to apologize about that, but I can't fix it. It's one of the things. Was that the issue that some of you were having with the angle, or did y'all get to that? So just remember that. It's just one of the quirks of these things. So let me go to the next one, that's okay. So when you answer, so help me figure this out. So there's a part A and a part B. So let's say you put in part A and you got it. Does it tell you right immediately? It tells you correct immediately, doesn't it? So then, if you go to part B and you enter it, and you enter the wrong number, can you enter it again at part B without changing part A? Okay. So just be aware of that, these goofy angles and stuff. Sometimes don't immediately assume you're wrong. Think about how he could have phrased it. And that angle stuff is one of those things that really is annoying. And I don't like it, but okay. I think I pushed it. Did I not push it? Okay. So this one's similar, although it's not scrolling. Oh, there we go. Okay. So every time I see it in here, I'm assuming he's changing those numbers for people here. This is a similar thing. Okay, so determine the magnitude, determine the direction of the measure counterclockwise from the positive x-axis. This time, last time was clockwise, right? Wasn't it clockwise, or did I read that wrong? Anyway, now he's wanting it to be counterclockwise. Okay, so, whatever. So in this case, it's a little bit easier. F1 is just equal to 0i plus 950 j. F2 is equal to, this is 30 degrees, so you got to grab part of that and part of that. So F2 is 700, in this case, 700 cosine 30i plus, but actually it's not a plus, it's a minus 700 sine of 30j. And so you add that to nothing, and you add that to that, and so your resultant is just going to be 700 cosine 30 plus 950. I forgot to put the I, sorry. And I might as well put a box around it. And then I'll say it like this, plus 950 minus 700 sine of 30, and then a j. So in that, this is the same case, the same situation. If you want to know the magnitude, you take that squared, add them together, and take the square root of them. So the resultant force will be number 1, I, plus a number 2, j. And this will be your number 1, and this will be your number 2. So you just calculate that. Again, okay, if you want to know, okay, so here's the thing with this. There are many ways to take these two numbers to find the answer. First of all, I know this thing is going up or down. It's going to have a value here. I know this is 30 degrees to that side. So I know the answer is, my bet is 950 is larger than 700 to begin with. So sine of 30 is going to cut 700 down, so this is going to be a positive number. So my bet is you're going to have to do this. This is a beneficial thing too, is to look at the magnitudes of the number and maybe just 5 seconds sketch it on a page. Doesn't have to be exact. So you get a little bit to the right and a little bit up, and so this is where you're going to be. So if you got a vector that sits right there, you're just looking for that angle, which I don't know what to call it, but I'll just call it theta. Now there's 2 or 3 ways you can find it. One is you already found the magnitude, so let's call this the magnitude, or F, okay, FR. There's your magnitude. So you could do this. You could say, well, the cosine of the angle is equal to the x component over the magnitude, which would be the x component squared plus the y component squared. And then you can take the arc cosine of that. Okay, that's okay. Or say maybe you like sines, you don't like cosines. And so this is the cosine, this magnitude times the cosine of that angle gets you that magnitude. But likewise, you get that one too. So that would be the y component. Oh, that would be 2. And the square root of that. But neither one of those is what he talks about in the book. What he talks about in the book is the tangent. So the reason I write these 2 down is because the tangent of the angle, and I'm going to do it off of this. The tangent is over that square root over that number and that square root. These things cancel and you get, 2. Okay, so let me do it like this. This is 1. This is the number 2. And this is the number 2 as well. And this is the number 1. So those are the links there. So, you know, you can take that over that, arc tangent it, and get the angle. Or some people like to do that. They already found the link, and you've got a verification that that's correct. So it's okay. It's just trick. It's just a matter of which one you want to do. You know, for example, we'll just take a case in point. 4, 3, and 5. Want to know the angle there. Well, cosine, whatever that angle is 4/5. And the sine of whatever that angle is, it's got to be 3/5. But what's the tangent of whatever that angle equals to? That's the sine of that over the cosine, or 3/4. So if we do this, I already got that there, so let me erase it. And let me see, I don't know how this will work. I've never done this, but here, I'll try this. Tangent inverse, I'm going to try. Okay, I'm going to use that photo math thing, but I don't know if it'll do inverse. I've never tried this. So I'm going to try this and see what it comes with each one of these. I don't know if it's going to give me radians. I don't know. I have no earthly idea what it's going to give me. The question is, what do I get? I don't know about that. Yeah, see, I'm not sure he's calculating this correct. Okay. He's putting something in there. Yeah,
Okay. So he's actually, when he sees this, he's turning it into something else. I don't know how to change that in this, but if I use my regular calculator, that may be a hole in this whole thing. So if I do an arc sine, oh, wait a minute. So if I do, let's start with cosine. That's a 0.8 second arc cosine. I get 36 degrees. 36 point, I'll just say 9. If now I clear that and I want to do 3/5, which is 0.6, and I do the arc sine, I get 36. That's something to be kind of scared of there. And then 3/4 is 0.75, and I get 36. So if you use PhotoMath and you enter that, it's not going to give you the right thing. It's doing something weird. What it's actually doing, it took this and it did this. It did that. That's what PhotoMath did. That's not what I wanted. I wanted to take that. So maybe in PhotoMath you need to do this. Let me try that. So let's try this arc sine 3/5. Because I need to know if I'm up here doing this and using this thing, what do I need to put in there? This is a good question. Let me see. Does that? Yeah. So it wants to see the arc sine. It doesn't want to see that. It sees this as 1 over the sine of 3/5. So it's up to you. This is what the book does. The book always uses the tangent, but there are many ways you can do that. You don't have to use the tangent if you like using the sine more than or cosine. If you're comfortable using the tangent, it's okay. So that's an individual preference. Three individual preferences. But you also have a check, you know. And then again, if he messes you up by telling you, I mean, I hate that, but say your angle is 60 and you know, you enter 60 and then you realize, oh, I could have entered minus 300. The answer would have been minus 300. Well, why would you do that? But I'm not going to ask why. It's just both answers are correct. For that matter, I mean, if you want to be stupid, you could go like that, and that's the right answer too. So, I don't know. That would be 6 minus 660 is the right answer too. I don't know. Why you would do that, I have no clue. So just be aware of the angles, Mike. Okay, so this one, let me see. This one is starting to make use of something that, you know, maybe you should talk, maybe as a book or a teacher, you should talk about it earlier. Maybe you shouldn't. I don't know. But let's look at this one, because this one actually has some connotations for later. It says resolve the force, the force is 500 pounds, acts on the frame as shown in that picture. Resolve this force into the components acting along AB and AC. In my mind, you know, they should delay this type of problem until later, but it is an opportunity to bring something up. And what it is, okay, so if this happened, okay, what is that, 500 pounds? If it happened, could this be a cable? What would happen if this was a cable when you did that? Your intuition, what would it tell you that would happen? It would just collapse, right? If you took These are pin jointed. See, that's the thing. He didn't even describe what pin joints are yet. So if you have something like this is a rod and this is a cable, and you pull 500 pounds, it's just going to flop. Okay, what would happen if this was a cable and this was a rod? Because he says it's a frame, but say this is a rod. Then this is a cable. Would that hold? You've seen it. Go down on Main Street. You'll see here's the building. Here's these things. There are people walking under them. And a lot of times there's just a cable right there. That cable is in tension. It's holding that thing from hitting that guy in the head. So in essence, this is the same thing. This could be a cable. Now we'll talk. We'll get more and deeper into these concepts. But in essence, what is happening here is that this force F, what will happen? Okay. It can happen so that this would be the forces that are in this thing and this thing. Meaning that this C would be pulling back on A, and B would be pushing up on A to make it so it would sit perfectly still. Now, and maybe I shouldn't assign this until like that next section where we start looking at these equations. But now we look at it and say, I got a vector. You can call it whatever you want. I don't know what to call it, so let's just call it F1 and F2. How about that? I don't know anything else to call them. So now I know this F1 and this F2, and I'll even mess up in a second if you want me to, and I'll show you something interesting. As a matter of fact, maybe I'll mess up now. So now that I've told you this, you buy into the fact that this has to be in tension or pulling, U-L-L-I-N-G, and compression or pushing. Let's assume I didn't know. And let's just say I'm just going to make a vector. I don't care. I'm just going to call this F1 and that F2. Let's do this enough and you'll see something come out of this. And I got enough time to complete this. And then there's the walking problem, which maybe I'll have to do that next time if I can. But I want to use this as an opportunity to show something interesting. So what I'm going to do is I'm just going to take F1 by its lonesome. Sits up here. It says, okay, so you got to play around with this a little bit. It's a little annoying. He told us this and this, but anyway, it's a little annoying. F1 shoots up 30 degrees, but it also, hang on. Okay. This is 45, right? Because that's 45. So that line shoots off there, and this line shoots off there. So if that's 45, that's got to be 45. Okay, hang on. So the blue line's 45. You know what? Maybe I should put that 45 back over here. So this is 45. So that makes that 15. Am I right? Does that make sense? So you got 15, 30, that's 45. Another 45 gives you 90, and you're okay. So essentially what you got is a vector. It looks like this. Hang on. It looks like this. Okay, so I'm just going to say it's in F1. Magnitude F1. Sorry. F1. Sorry. F1 is equal to the magnitude of F1. First I'll do this. Cosine of 15. Okay, so I better put the 15 in here. I plus the magnitude of whatever that F1 is times the sine of 15, right? J. Now I'm going to peel off the F2 by itself, like up here somewhere. So here's my F2, but it's kicked up 45 degrees. So it's 45 degrees. If you stare at it for a minute, it's 45 degrees. So you're like, what do you do here? Well, that means the F2 vector is equal to whatever the magnitude of it is times cosine of 45i plus whatever the magnitude of it is, I don't know, times sine of 45j. Okay. And then, you put this one together with this one, and you should get that one. Okay, well this one is pretty easy. It's minus 500j. It points straight down. That's what it is. That's it. I mean, that's that vector. This is this vector, this is this vector. Now, I already made this thing where this had to be pulling, right? So let's see if this self-corrects. Okay, so this means, what I mean by that is you can assume, you'll find out as time goes by, you can assume something. It'll self-correct it. And so, let's go ahead and do this. So what I need to do is add this one to this one to equal to that one. So in other words, he says, resolve this force to components acting along member AB, that's this, and then this. So I add this and this, it's got to be that. Let's see what gets self-corrected. Okay. F is this, which is equal to 5 minus 500j. Minus 500j. Now this will take a little bit of a gathering and understanding here, so you'll just have to be patient with me here. So I want to add F1 plus F2. So what I'm going to do is add this and this one. So F1 magnitude cosine of 15 plus, I'm adding this to that, F2 magnitude cosine of 45. And that's got to be the I component. So I'm adding the two I components, and then I got to go in and add the two J components. F1 sine of 15, which is that one, and then I'm going to do this one. Oops. F2 sine, 45J. Now, if I had to look at this component, and you had to say this, okay, so this, okay, on the left, on the right-hand side, you see a number times I, and you don't see that over here. So that implies that F1 cosine of 15 plus F, that's supposed to say 2. F2 cosine of 45 has to be equal to 0. That comes from the I equation. From the J equation, you see a minus 500 has got to be equal to F1 sine of 15 plus F2 sine of 45, and that comes from the J equation. So you got two equations and two unknowns. Solve for this one. I mean, I don't know how you want to do it. Later on, you will find that I use MATLAB almost exclusively because I like to set these up in matrices. I don't know if I want to do it right now, but maybe I'll do it and see if this photomath will solve a matrix. So let's try that. So what I'm going to do is I'm going to say this is equation 1 and this is equation 2. This is equation 1. This is equation 2. My unknown is F1. I'm just going to say, I don't want it to look too complicated because I don't know what photomath will do here. So I'll say F1 and F2. That's these terms equal to, this should be really interesting. Okay, so I'm looking, okay, so F1 and F2. Okay, so in the F1 part, I've got a cosine 15 degrees. In the second equation, in the first equation, the F2 is I get, and I may have to erase some things, cosine of 45 degrees. On the right hand side, I get nothing. Now look at the second equation on the right hand side, I've got minus 500. Over here, I've got F1, so I've got sine of 15 degrees. And then I got sine of 45 degrees. So I've got a matrix. What I'm going to do is kind of clean up around it and use that photo math and see, can it even solve that? I mean, I don't know. Second thing is I probably need to be further back to get it all in there. I do not know. First of all, my shadow of my head probably does not help. This will be really intriguing. Oh, it does. Find the unknown matrix values. It gave it to me, but it has a square root of 2 stuck in it. F1 500 square root of 2. Why won't it give me? It won't give me the actual numbers, but I don't know. Minus 250, square root of 2, minus 250, square root of 6, and for some reason that minus sign is kind of faded out on the solution. And I don't understand why. Let's see, if I just do this, what happens? Okay, this is true, this is true. And it doesn't calculate it out for me. Okay, so let's try that one. Okay. I don't know. Well, in any case. So what has happened here? So what's happened is it did not flip that one. It flipped this one. Now, here's what I'm going to do. Okay, and this may take a few minutes for you to kind of comprehend. So, and we do this later. So let's take this thing and break it into its two components on this object right here. So on this object, what you see is you see this force. This force is equivalent to pushing along the F1, which is, wait a minute, I've already erased them. Which one's the F1? F1 was this, wait, it was this one. So it's equivalent to, oh crap, I erased mine. Okay, so it's equivalent to that. And then F2, which I had going this way, is actually going that way. So in other words, if I erased this and pulled on this member and pushed on this member, these two go together to be equivalent to the other, right? Now, if I'm pulling on this member, which means I'm erasing this force, and I'm pulling on it, then the member has to pull backwards. And if I'm pushing down on this member has to push the other way. So it's equal and opposite reaction. So in other words, it depends on the way you look at it. If you, and we'll see later, there's another way to look at this so you can get the signs. The signs will be flipped, and I like it better the other way. This is just an introduction to that type of thinking. And the phone showed that was the answer. The square root of 2 500. It probably is. The key is that swap the sign on the F2. So if you've got something and you assume it and it gets an answer, it'll self-correct and flip it over. So you don't have to be like an expert and an all-knowing seeing person to put the force on there the right way. You just have to put it on there in the right direction, and the math will flip it over for you. Then it's up to you how you want to correct the drawing. And we'll see some free body diagrams and stuff like that in which, sometimes it's beneficial to go back and erase it and flip it over right then and go on. And sometimes it's okay to leave it that way. So he says determine the AB component, determine the BAC component, or the AC component. In these two cases, I think he's just wanting the magnitude, so it doesn't matter whether you assumed it the right way or wrong. You just take the square root of the squares. But in this case, you didn't do that. One's that, the other's the other. But like I said, I don't know why in the solution that was a really dim minus sign. And that I don't understand why it was so dim. I don't know if it was just the software making it dim or if it implied anything. I just don't know. But when we get to this section, you're going to find I'll use the matrices a lot, and I'll show you. I'll relate using matrices to the unit vectors, and there's a relationship which is always there. And I would say definitely read the book and follow him, but also I'll extrapolate from that and show you that all these problems can be encompassed by using the matrices, and they always work if you always focus on the unit vectors. But we'll see when we get there. So,
And I don't know. Do you want to do the next one next time? Do you think that's enough to get? Wait, did I do that one? Did I give you that one? I guess I did. Was that one of them too? Okay. Can I do that one next time? Because we're getting close to the end. Yeah, watch for snow and ice conditions. Okay, so it looks like it might. I don't know, I'm getting all sorts of messages. It looks like this morning it said 0.1 inches possibly. And then a few hours ago it said 0.25. And just like that snow the other day. We were over at the high school driving away. And several of the high school teachers were like, oh no, it's not going to be anything. We come down from the high school to Walgreens. And at that point, I realized, uh-oh. So we went from Walgreens up to Crow Mountain. By the time we got out there, it was like 1 inch to 2 inches. And it wasn't even supposed to start till 6. So I don't really know anything about the weather except that you can't predict it very well. So we may be here Wednesday, we may not, I don't know. But if we're not, we'll pick it up and solve all of this. So don't worry, just keep attempting it, and we'll come back and do this one next time. And then there's another one about the traveling person who's like Auntie Em and Toto were going this different direction or something, and they kept caught up with each other. It's just a bunch of vector addition. But the word problem is so confusing that you got to draw it out. So it wasn't Auntie Em and Toto, or no, Dorothy, or whatever. You know what I mean? It was Brother Jack and Jill or something. I don't know. But we'll find that problem in there too. I think it's in there. If it didn't, I took it out. It's okay. So I guess I'll see you next time.